Alright, good to see you back. So this is another lesson in using sum and difference formulas. Okay, what are we doing this time? So this time we are doing proving trig identities. It's always the best thing in trigonometry. So how do we prove it? Still remember? So we have sine of alpha divided by 2 plus theta equals to cosine. So we have left hand side equals to the right hand side. To prove, we pick one of the sides, usually the one that is more complicated. So left hand side, that is sine pi over 2 plus theta. And then the next step is you have to do everything you can. It's like building a bridge. You are in point A, you want to get to point B, you pick point A. So this is your first step. You want to build a connection until you want to build a bridge until you reach to point B. So you don't work on both sides at the same time. Do not change the given identities, all right? Use whatever is given. So I take LHS, and then what do? We apply the sum formula. So we have sine of alpha, sine of pi over 2 times cosine theta, and then plus cosine pi over 2 times sine theta. So this is alpha, this is beta, right? So the one that we are using is this. So that's the one we just use. And then you have to tell me what pi over 2 is. So pi over sine pi over 2. Pi over 2, what is the coordinate? That is 90 degrees. Is on the y-axis between quadrant 1 and quadrant 2. The coordinate is 0, 1. So sine is 1. Sine is y, right? Times cosine theta. And then cosine pi over 2 is 0 times sine theta. So you only have cosine. That is equals to the right hand side. So the job is done. That's how you write a proof. Again, do not start on both sides. If you start on both sides, the whole thing is wrong. You are not going to get a single points for it. Number 2, you have cosine pi minus theta that equals to negative cosine theta. So this one I will pick the left hand side. Left hand side because it is more complicated. So pi minus theta that is equals to cosine pi times cosine theta plus sine pi times sine of theta. And then you have to tell me what is the coordinate of pi. That is in between quadrant 2 and quadrant 3 on the x-axis. So we have negative 1 comma 0. Just go look at your unit circle. That is negative 1 cosine theta plus sine is y, 0 times sine of theta. So you have negative cosine theta that is equals to right hand side, and then your job is done. It is just that easy. Let's do one for tangent. So C, we have tangent pi minus theta that is negative tangent theta, and then the left hand side you have tangent alpha minus theta. So you have tangent theta minus tangent pi minus tangent theta, and then 1 plus tangent pi times tangent theta. And then this pi is negative 1, 0, right? So you have tangent pi, that is y divided by x, 0 divided by negative 1, that is equals to 0. So this is a 0 minus tangent theta, and then 1 plus 0 times tangent theta. So you have a negative tangent theta divided by 1. So that is your right hand side. The job is done. Not too difficult, right? And then the next one is requires more work. I'm not going to just give you a couple simple problems in my video. So in part D, you have sine of alpha plus beta divided by sine of alpha cosine beta, that is equal to 1 plus cotangent alpha times it's not cotangent, sorry, times tangent beta. Okay, let's do it. I am going to take the left hand side because I can apply the sum formula. So left hand side, so that is sine of alpha plus beta, and then sine alpha cosine beta, and then let's apply the sine first. So that is sine alpha cosine beta, just like A and B, plus cosine alpha, and then sine of beta, and then divided by sine alpha cosine beta. And then the next thing is I want to review something that is very fundamental. So let's change colors for now. So let's say I have 1 plus 2 divided by 4. Another way to write this is 1 divided by 4 plus 2 divided by 4, right? You get 3 over 4 anyway. So in this problem, there is only one denominator. So we can go ahead and do sine alpha cosine beta divided by sine alpha cosine beta, plus, the plus is from here, plus cosine alpha sine beta divided by sine alpha cosine beta. And then we have to cancel something, simplify. This is equals to 1, right? And then this one gives you what? Cosine divided by sine. That gives you a cotangent. This one gives you a tangent, right? So at the end of the day, what do you have? You have 1 plus cotangent alpha times tangent beta. That is the right hand side. Your job is done. Looking cool, right? Next, part E. You have sine of alpha plus beta divided by sine of alpha minus beta equals to tangent alpha plus tangent beta divided by tangent alpha minus tangent beta. This one, which side do you want to get? I want to start on the left. So we have left hand side, that is equals to sine of alpha plus beta divided by sine of alpha minus beta. That is equals to, you just apply the sum and difference formula, right? So sine alpha cosine beta plus cosine alpha sine beta. And then you have divided by sine of alpha cosine beta minus cosine alpha sine beta. This we are going to multiply by a magic 1. So what is that magic 1? Let's do that in pink. So the magic 1 is we want to have 1 divided by cosine alpha and then cosine beta. And then this is 1 divided by the same thing. Why do I have to do this? The reason is I see a tangent alpha right here. So as long as I take the sine divided by my cosine, there is a chance to get tangent. Look, you have to end up with a bunch of tangents. We have sine and cosine. There is no way to end up with a tangent like this. So you must divide it by something to get a tangent. That is the direction. Okay, going back to my problem. So this one I have this term divided by this, and then this term divided by this, divided by that, just like what you did right here. Just like what you did right here, using this concept. Okay, back to orange. So I have a sine of alpha cosine beta divided by cosine alpha cosine beta, and then plus cosine alpha sine of beta divided by the pink denominator. If you want to see it well, right here, you got here and there. All right, so back to the orange, we do the same thing for the denominator. So big fraction bar, we have sine alpha cosine beta divided by the pink, and then minus cosine alpha sine beta divided by the pink. Can we do some cancellation? Let's see. Cosine beta, cosine alpha, cosine beta, cosine alpha. So the leftover, what do we have? Looks like we are able to get to the tangent, right? So for the leftover, we have sine divided by cosine alpha, so that is tangent, and then plus tangent beta, and then this is tangent alpha minus tangent beta. So we are done. That is the right hand side. So this is done. Moving on to the last one. The last one you have to do something similar. So part F, you have negative cotangent alpha minus beta, that is equals to cosine alpha minus beta divided by sine of alpha minus beta. We have right hand side. So right hand side, that is equals to cosine alpha minus beta, and then divided by sine alpha minus beta. You apply the difference formula. Okay, so you have cosine alpha, cosine beta, plus sine alpha, sine beta, divided by sine alpha, cosine beta, cosine alpha, and then sine beta. So let's erase this fraction bar because I'm going to put something in there. So what we are going to put in there is we are going to multiply 1 divided by sine alpha, sine beta, and then 1 divided by sine alpha, and then sine beta. So the green fraction is equals to 1, right? Why do I have to do this? Because look at the first term here. We have a cosine, and then here we have a sine, right? Cosine divided by sine, I have a good chance to get to the cotangent. That's the reason. Okay, going back to the problem, so that is equals to 4 big fractions, right? So cosine alpha, cosine beta, divided by sine alpha, sine beta, nothing can be cancelled, and then plus sine alpha, sine beta, divided by sine alpha, sine beta. The entire fraction can be cancelled. And then this is a sine alpha, cosine beta, divided by sine alpha, sine beta, minus cosine alpha, sine beta, divided by sine alpha, and then sine beta. So let's do some cancellation using another color. So this is cancelled, right? But it's not equal to 0. So basically this whole thing is equals to 1. And then what about the denominator? So this and that becomes a 1. And then sine alpha and sine alpha, right? So let's pick up the leftover. Going back to orange, so the first one, let me divide it up for you. So this gives you a cotangent, right? 1 for alpha, 1 for beta. So we have a cotangent alpha, cotangent beta, which is the reciprocal of cotangent. The reciprocal of tangent, sorry, plus 1 divided by, what about the denominator? Cosine sine, we have a cotangent minus a cotangent. Is that all? If you look at the formula of sine, not sine, the tangent, we have alpha goes first, and then alpha, this one must be positive. So what we are going to do here is, I can do that in another color so you won't be confused by the minus. So let's say you have a b minus a. I can swap them, a plus b, and then factor out a negative 1, so that becomes a minus b. This technique exists. So the top, I have 1 plus cosine alpha, cosine beta, not cosine, cotangent alpha, cotangent beta, divided by, you take the negative 1 out, times cotangent alpha minus cotangent beta. So that is equals to negative cotangent alpha minus beta. So that is equals to the right hand side, and then the job is done. And then this is the reciprocal of tangent alpha minus beta. Of course, we have to change all the tangents to cotangent. Alright, so that will be all in this lesson. I will see you all in the next video.